and I did the audio recording separately, so the audio sounds a lot better than normal. So I just turned that on, so we'll have that again for today. Okay. Now let's go ahead and factor this. So notice we can take a greatest common factor out of this term. That's an x cubed. So we can take x cubed out, and we're left with x squared plus 2. Now we already see some things that we can cancel, but maybe let's not do that just yet. Now, can we factor this x squared minus 2x minus 3? I think we can. We need to look for two numbers that multiply to -3 and add to -2. So x minus 3, x plus 1 will fit the bill there. Good. Now we're left with this one. So I saved this one for the end because we've got a coefficient of 2, which generally makes it a little bit trickier to factor. But we've got some contextual clues within the problem that might help us factor it. Like, this isn't guaranteed, but often these are built in a way so that we've got cancellation. So it's possible that one of these guys down here, x minus 3 or x plus 1, will cancel with the factored version of 2x squared minus 5x minus 3. So that gives us a hint for how to factor this. So first off, we know it's got to be 2x in something and x in something, because 2 is prime, so the only way you can factor it is like 2 times 1. Then we know that 3, the only way you can factor that is 1 times 3, so that means we put a 1 here, a 3 here, a 1 here, or a 3 here. And then we've been just doing guess and check until it works out. I think, I know a lot of people, I know when I was a student, at least, I was very hesitant to use guess and check technique, but it's very, very powerful technique, and it really builds a lot of like intuition and a lot of like just gut feelings for how to approach problems. So even though it doesn't seem very precise, it's a very important technique to come to grips with. Okay, so let's see. We need to get a minus 5 here. So how can we do that? I think we can do that if we put a minus 3 here and a plus 1 here. So let's see, does that work? We've got x plus 1, that's x. 2x minus 3, that's minus 6x. That's going to give us minus 5x. So it worked. Now we can go ahead and cancel things. So notice this x squared plus 2 is going to cancel this x squared plus 2. This x minus 3 is going to cancel this x minus 3. And then we're left with x cubed times 2x plus 1 over x squared minus 2 x plus 1. And as far as I'm concerned, that's like done. You could multiply the numerator and the denominator out, but you get something that's equivalent. So that's as simple as we can make it. So we've got a rational expression. Okay, let's look at some more. Okay, let's maybe do this one yet. Next, 5 over w minus 3 minus w plus 2 over w squared minus 9. Good. So always we want to take inspiration from a similar type of problem that you would do just involving numbers. So if we had two numbers and they were exhibited as fractions and we were trying to subtract them, we know that we would have to find a common denominator. So that's exactly what we're going to need to do here, is find a common denominator. But finding a common denominator when you've got polynomials as part of your fractions is a little bit tricky. But if we fully factor all of the denominators, that'll be a big help. So maybe that should really be maybe your first step whenever you're doing these kind of things, is rewrite everything with factored denominators. So factor denominators. That'll just give you a feel for what the common denominator should be. So let's go ahead and just rewrite this with a factored denominator. So notice w minus 3 can't really simplify. And here we have w plus 2. Now we have to think about how to factor w squared minus 9. So that's a difference of squares. So we'll factor it like w minus 3 times w plus 3. Good. Now we just look at what's missing. So notice the denominator here is w minus 3 times w plus 3. Here we just have w minus 3. So we can give each of these a common denominator by building this denominator up until it is w minus 3 times w plus 3. So in other words, we need to multiply this by w plus 3 in the numerator and the denominator like that. Okay, so let's see what that gives us. That's going to give us 5w plus 15. That's what we get from distributing out this 5 times w plus 3. And then in the denominator, well, I'm just going to write this as w minus 3 times w plus 3 minus, and now we have w plus 2 over, and then we still have w minus 3 times w plus 3. Now let's see what we can do here. We can put these together and combine the like terms. So we've got 5w minus w. So that's going to give us 4w. We have 15 minus 2. That's going to give us 13. So we've got 4w plus 13 over w minus 3 times w plus 3. And, you know, I don't know, if you want to multiply it back out, you can most definitely do that and get 4w plus 13 over w squared minus 9. But that's kind of swings and roundabouts. They're the same thing. Now, I guess I should say one last thing that you should do is see if it is possible to simplify this. In other words, can we factor the numerator in a way that will cancel out with something in the denominator? But the answer here is no. We can't factor that numerator at all. Notice we've got just a linear term in the numerator, so the only possible factorization would involve a greatest common factor, but 4 and 13, they don't share a greatest common factor, so we can't factor anything out, so we're good to go. We're done here. Okay, so let's maybe take a second to try two problems that are in the same vein as these. So let's try this first one, which is a division problem involving these polynomials. So let's say it's like this, x squared minus 9 over x squared divided by x squared minus x minus 6 over 3x. So I'll give you guys like maybe 3 or 4 minutes to work on this, and then we'll go over the solution for this, and then we'll repeat that with a sum of two rational functions as well. The thing that we want to do is change this to a multiplication problem instead of a division problem, and then factor everything. So this step 1, which was factor the denominators, that is really kind of after this step 0, which is change everything to multiplication or, you know, addition and subtraction. The thing is like you really want to eliminate the division out of the situation for the first, as your very, very first thing, and then you can factor the denominators or factor everything and start simplifying. Okay, so let's go ahead and do that. So we've got x squared minus 9 over x squared times 3x over x squared minus x minus 6. We can already maybe see that the x and the x squared are going to cancel in some way or another. But perhaps this other stuff will cancel as well. So let's fully factor everything that we can to see what will simplify. So we know x squared minus 9 can factor into x minus 3 times x plus 3 over x squared. We still have that, which I guess we could write that as x times x if we wanted to, but you know, I don't know that we gain very much by that. And then we have that as multiplied by 3x over. So let's see how we can factor x squared minus x minus 6. So we know it's going to factor with x and then plus or minus something times x plus or minus something. just because we have a coefficient of 1 here. That makes it all like fairly simple. Now what we want to do is find two numbers so that when we multiply them we get -6, when we add them we get -1. So let's see, -3 and +2 will work here. And I guess I should point out that we should maybe take inspiration from the fact that we've got one of those up here so that that'll like help us make our guess. Okay, so now let's simplify what we can simplify. So this x minus 3 will cancel with this x minus 3. This x squared will be canceled down to an x to the first power by canceling out that x in the numerator. Now we'll have 3x plus 9. So I multiplied the 3 through. And then multiplying the x through will be x squared plus 2x. So we didn't need to multiply those three. We could have left them factored if we wanted to, but you know, we might as well multiply them through like this. So I would say that would be a good place to stop for this one. So we've simplified it down quite a bit. Okay, so I'm gonna give you guys another one. To try, and then a few minutes to do that one, and then we'll do some more. So let's say here's another little exercise. Let's say it looks like this. 3 over y squared minus 8y plus 16. Maybe minus y plus 1 over y squared minus, sorry, y cubed minus 16y. Yeah, okay. We want to factor the denominators because our goal is different. Our goal isn't cancellation like it was when we were doing multiplication or division. Our goal is combination. Maybe our secondary goal after that will be to cancel everything down, but you know, we'll get to that when we get to it. Okay, so like I said before, we want to factor all of the denominators, and that's because we want to build ourselves up to having a common denominator. So let's see if we can do that. We've got 3 over, now y squared minus 8y plus 16, we see that that's going to factor like y minus something, y minus something. That's because we've got a plus here, we've got a minus here. So we know two negatives multiply to a positive, but they're going to add to a negative. Now we want to look for two numbers that add to -8 and multiply to positive 16. So 4 and 4 work here. So we just reason that, but that's also like one of our like standard special factorization cases. Okay, good. So let's see how to do this other part. So we have this is minus y plus 1 over. Now let's see what we can do with this. So maybe as an intermediate step, I'm going to take a y out, and then we've got y squared minus 16. Okay. Just because we've got a greatest common factor of y in each of those, y cubed and then this 16y thing. But that's actually more helpful than it might have seemed because now we've got a difference of squares over here. We have this y squared minus 16. So that's going to be factored like y minus 4, y plus 4, again using our standard like factorization trick. Good. Now we can start building up the denominators. So let's see what we're missing in each part. So over here, we are missing a y and a y plus 4. Because notice this includes a factor of y and a factor of y plus 4. So we'll multiply the numerator and the denominator by y times y plus 4. And then let's see what's happening over here. Over here, we're missing just a y minus 4, right? Because this has 2 copies of y minus 4, but this has just 1 copy of y minus 4. So we can multiply this by y minus 4 and then y minus 4 down there. Okay, so let's see. Now let's expand the numerators. So that's going to give us 3y squared plus 12y. So that's what we get from distributing this 3y onto y and then y plus 4. And this is all over this denominator, which is pretty big at this point. So we've got y times y plus 4 times y minus 4 squared. So I'll just write it like that. We've got y minus 4 times y minus 4. That's y minus 4 squared. Now we're going to subtract from that this product. So let's see what we get for that. We're going to get y squared. And then we're going to have minus 4y plus y. So that's going to be minus 3y. Minus 4 times 1 is minus 4. So we get that. And then we have the same denominator. So y plus 4, y minus 4 squared. Okay, good. So now let's see if we can simplify that at all. And we can. So notice that we can take this minus sign and distribute it onto everything in here. So here we're thinking about being in the numerator of the fraction as being grouped together. So I changed all of the signs, and now I can just subtract across. I have 3y squared minus y squared. That's going to be 2y squared. I have 12y plus 3y. So that's going to be 15y. And then I have, well, 4 is what's left. So plus 4. And then this is going to be all over y times y plus 4 times y minus 4 quantity squared. Okay. Then the very, very last thing that we'd want to do is see if it's possible to factor this numerator. And I would say just doing this by like guessing and checking. So let's see, this is going to be equal to 2y with something and y with something. We know we have a plus attached to each one because their product is positive and their sum is positive also. So let's see, now we need to split up 4. We can split that up as 4 times 1 or as 2 times 2. But notice neither of those will work. If we put a 4 here and a 1 here, we'll get 8 plus 1, which is 9. That doesn't work. If we put a 2 here and a 2 here, that also doesn't work to give us 15. So in conclusion, this thing is not going to factor, which makes this expression like the final answer. Okay, so that's as simple as this one gets. Okay, so let's maybe look at a couple that are maybe have a different look to them. And that makes them a little trickier. Okay, so let's maybe look at this one. 2 over 4 minus x plus h minus 2 over 4 minus x, and this is going to be all over h. So this may seem like needlessly complicated, but this is a really important example of something called the difference quotient, which we'll see later, which will be super important in the first semester of a calculus type course. So the first goal is to combine these two things that are in the numerator of this complex fraction, which means we need to give them a common denominator. So notice we've got two denominators happening. We've got 4 minus x plus h, and then we have 4 minus x. So we need to build those up until they are the same denominator. So we can do that by multiplying this one by 4 minus x plus h, like that. But that means we need to multiply the numerator by the same thing, 4 minus x plus h. Then we need to build this denominator up as well. We can do that by multiplying by 4 minus x. So let's fit that in here. So 4 minus x, and then we'll multiply the numerator by 4 minus x as well. So notice that's what was missing in this term. Here we have a 4 minus x, so we had to include that in this second one. In the first one, I should say. Okay, so let's see what that gives us. So 2 times 4 minus x, that's going to be 8 minus 2x over, now I'm going to rewrite this as 4 minus x times 4 minus x plus h, and just leave it like that. So that's the product of these two terms that I use to build this denominator. Okay, and then I have minus, so the next thing that I want to do is maybe distribute this 2 onto all of these. So we'll have 8 minus 2x minus 2h. And then notice while I was at it, I distributed this minus sign through as well. So that's what we get for the numerator of the second term. And then that's going to be all over this same thing, 4 minus x times 4 minus x plus h. So we have something like that. Now we have common denominators, so we're good to go on that front. We want to combine these at this point, which means maybe we'll distribute this minus sign onto all of the terms in that big numerator. So we can do that by changing it to a plus and then changing the sign on all of those. So let's see what that gives us. That gives us 8 minus 8, so that's going to cancel. We get 2x minus 2x. Well, actually, it's negative 2x plus 2x. And then we're left with this 2h. So let's see what we have there. So this is going to be equal to 2h over, and then we've got 4 minus x over 4 minus the quantity x plus h, like that. And then I would say this is a good place to leave this one. So again, the game here was we simplified what was happening in this numerator. So let's maybe look at a couple of more, just simplifying these expressions, and then we'll move on to solving equations involving rational functions. So in other words, like rational equations. Okay, let's maybe look at this one. So 10x times x minus 3 to the negative 1 minus 5x squared times x minus 3 to the negative 2. Okay. So this may not seem like a rational expression because there's no discernible denominator, but if you remember that negative exponents are the same thing as inserting those things into the denominator, then you see that there is something with the denominator. So that's our first step here, is we want to write these things so that they are honest to goodness rational expressions with denominators. In other words, we want to use the fact that negative exponents send things downstairs. So let's go ahead and do that. So this first one is going to be 10x over x minus 3 to the first power. So what I want to point out here really carefully is that this minus 1 is only the exponent of x minus 3. So since that minus 1 is only the exponent of x minus 3, that's the only thing that goes down to the denominator. The minus 1 is like not touching this 10x. That's why it stayed in the numerator. Then the same kind of thing goes over here. So this is going to be 5x squared over x minus 3 squared. And that's because this minus 2 is only the exponent for the x minus 3. So that sends it downstairs, but since it's a minus 2, it's squared. Okay, so now we need to start finding common denominators. So our common denominator will be x minus 3 squared. So we need to build this first denominator until it looks like x minus 3 squared. So we can do that by multiplying by x minus 3. So we multiply by x minus 3 like that. Let's see what that gives us. So we're going to have 10x squared minus 30x. So that's what we get from multiplying the 10x through onto the x minus 3 over x minus 3 squared. So that's what we get for multiplying x minus 3 times x minus 3. And now we have minus 5x squared over x minus 3 squared. And now we're all set to simplify. So we've got 10x squared minus 5x squared. That's going to leave us with 5x squared minus 30x all over x minus 3 quantity squared. And then you might want to try to simplify this by factoring out the numerator to see that if it cancels with the denominator. So maybe we would write this as 5x times x minus 6, but notice that that is not going to cancel with the denominator. Doesn't include any of the common factors, so that's not actually that helpful. But if you wanted to, you could rewrite this as 5x times x minus 6 over x minus 3 quantity squared. You just can't simplify it any further. Okay. So now let's talk about rational equations. So in other words, equations involving these rational functions. So let's maybe put a heading for this: solving p of x over q of x equals 0. So the fact that you want to use here is that a fraction is 0 only when the numerator is 0. So to solve this, so maybe we'll put this: to solve this equation, you want to find all of the numbers x that satisfy the following conditions. So p of x is equal to 0, but q of x is not equal to 0. So if they're both equal to 0, well, then you have 0 over 0, which does not have a well-defined value. There's ways of getting a value out of it, but not ways that are like really available to us. They'll be available like in a calculus class or something. So those are the conditions that we want to satisfy. So let's look at a little example first. So let's look at this example: x minus 1 over x squared minus 4 equals 0. So if we want to solve that rational equation, well, then that means we want to solve x minus 1 equals 0, because that's the numerator. A fraction is 0 when the numerator is 0, but that tells us that x equals 1. And then we want to check that if we plug this value of x into the denominator, we do not get 0. So in other words, 1 squared minus 4 is equal to negative 3, which is not equal to 0, which means we're okay. So I should say, maybe let's break this into parts. So this thing right here, solving p of x equals 0, is finding candidates for solutions, maybe finding possible solutions. So let's say finding possible solutions. And then this part over here, where we're plugging it into the denominator and making sure that that's not equal to 0, is checking the possible solutions. So unlike when we were looking at polynomials, we just had to find them because we were always guaranteed to have one using our methods that we discussed in class. With rational functions, or rational equations, I should say, we have to find possible solutions and then check the possible solutions, just like we did here. Okay, so now let's maybe look at an example where this might go horribly wrong. So let's look at this one. So let's solve x squared minus 1 over x squared minus 2x plus 1 equals 0. Okay, so there are two steps. We want to find the possible solutions. That'll be like step number 1. And then we want to check those possible solutions. That's step number 2. So maybe step number 1, find the possible solutions. That means we're going to take that numerator and set it equal to 0. In other words, we're going to take x squared minus 1 equals 0. Now we got a bunch of ways to solve that. We can factor it. We can move the 1 over and take the square root. Any way that you do it, you get x equals minus 1 or x equals plus 1. But that's only half the game here. Now, not only do we want to find those possible solutions, but we want to check them. So maybe let's do that now. So we'll check that these solutions are solutions, or maybe they're not. And we'll do that by plugging those into the denominator. So we'll do minus 1 squared minus 2 times minus 1 plus 1. So that's plugging, maybe we'll color code this. That's plugging minus 1 into the denominator. Let's see what that gives us. That gives us 1. Negative 1 squared is 1. And then plus 2 plus 1, so that's 4. So that means, yes, we're okay. This is a solution. We can keep this one. Now let's check the other one. So let's plug 1 into the denominator. And notice that that gives us 1 squared minus 2 times 1 plus 1. But that is 0, right? That cancels out. And that tells us that we have to discard this one. So we can't keep that one. That is not a solution. Okay. And you can actually get away from doing any of this by simplifying the rational function as much as possible first. So let's notice that we can factor the numerator, like x minus 1 times x plus 1. And then you can factor the denominator, like x minus 1 quantity squared. So now that equation that we started with turns into this equation after doing all of the factoring. Now we can go ahead and take this x minus 1 and cancel it with 1 copy of x minus 1 in the denominator. And then notice that the only solution for the numerator equals 0 is the one that we kept in the first place. So that's the only solution that we have for the numerator equals 0 in the first place. Okay, so you can like skip this checking step if you simplify the rational function as much as possible. Okay, so let's see. I think maybe that's a good place to call it for today. And we'll pick up next time doing more of these equations involving rational expressions or rational equations.